Okay, so today we will discuss about this timer or counter operation. Okay, so this timer or counter operation here in the 8051 microcontroller, we have seen that there are two timer or counter operations, and this timer and counter operations are complementary operations. At a time, we cannot do the counter operation as well as the counter operation. So here in the timer, to generate the time delay, and the counter can be used to count any external event. So for counting the external event, we can use the counter. Other than this, for any kind of delay generation or delay, we can generate some delay using this timer counter operation. Timer operation. So here, as we have discussed that there are both timers. I mean, two timers are there. So these two timers are nothing but timer 1 and timer 0. So this timer 0 and timer 1, both the timers are 16-bit. And if you can remember the register organization of 8051, then just see there are two parts of this 16-bit timer or counter register. One is this timer 1 high and timer high low, and another is timer 0 high and timer 0 low. So that is TL0, TL1, TH0, TH1. Okay, so this 16-bit timer is accessed to separate register of low byte and high byte. Okay, so clock source of the timer is the 1/12 of the crystal frequency. Earlier we have seen that this kind of timer operation, I mean for delay calculation, delay generation, we have used some registers like R1, R2, this kind of registers. So here we will not use any kind of register, but we will use the timer to generate the delay. Okay, so you can see this is the timer 0 register has been shown. The same structure is available for timer 1 also. Here timer 0 we have taken, that is denoted as TH0 and TL0, that means timer high 0 and timer low 0. And this timer 1 is the same timer, same as timer 0, but high and low bytes are referred to as TH1 and TL1 for timer 1, timer high 1, timer low 1. Okay, and these timers are can be used as a timer or counter. So there are two operations. So these two operations used here, just a minute. Yeah, so there are the registers that will tell the timer or counter or the microcontroller that the timer can be used as the counter or timer. So this particular operation is done by the TMOD register that was in the internal RAM organization part. These are special function registers. So this special function registers, you can see this is the bit pattern of this TMOD register, this part. Okay, this is the bit pattern of this TMOD register, and you can go back to the internal RAM structure that this TMOD register is not bit or addressable, that cannot be accessed by bit. So we should load our data completely, 8-bit data completely into this TMOD register. Now we will TMOD, that means timer mode selector register. So this timer modes can be selected by using this TMOD register. Now first bit, that is MSB, that is the gate. You can see these upper 4 bits and lower 4 bits are same. Clear or not? You can see this gate C/T bar, that will be T bar, and here also that will be T bar. Okay, so these two things are same, upper 4 bit and lower 4 bit. Now why? We will come. So this you can see the first bit, that is the gate. That gating control, when this is set, the timer or counter is enabled only while the INT1 or INT0, INTX pin. There are two interrupts, INT0 and INT1, or the either of these two pin is high and the TRX control pin is set. Okay, and when cleared, the timer is enabled whenever the TRX control bit is set. Now C/T bar, that will be complement. Okay, that means C/T bar means when this bit is set, that is 1, then it will act as the counter, but when it is 0, then this bit will be acting as a timer. Clear or not? So another 2 bits, that is M1 and M0. This M1 and M0 is nothing but the mode selection bits. These mode selection bits you can see in the chart. That is, there are some 4 bit patterns, 0, 0, 0, 1, 1, 0 and 1, 1. So there are 4 modes. Okay, so there are 4 modes of timer, that is 13-bit timer mode, 16-bit timer mode, 8-bit auto reload mode, and split timer mode. So if we suppose we are using a 13-bit timer mode, and the timer will be acting as the the timer register will be acting as a timer operation, not counter operation. Now what will be the value of this TMOD register? Can you tell me, anyone? Anyone can tell me? Now let me tell that firstly, that 13-bit timer mode, what I have said, that 13-bit timer mode is required. So 13-bit timer mode, that means M1 will be 0, M1 will be 0 and M0 will be 0. So these two will be 0, 0. Okay, and this should be activated, so it will be 1, and this is the timer operation, so it will be 0. Clear? Now you can ask that, sir, what is the function of this upper bit and lower bit, upper 4 bit and lower 4 bit? Now this upper 4 bit, you can see this upper 4 bit is used. We will see that how this bit is used. This upper bit is used for the timer 1, and lower bit is used for the timer 0. Clear? This part is for T0, timer 0, and this part is for timer 1. Clear? Is it clear? So if we are using timer 1, so this bit pattern, and this will be all 0. Clear? So this will be the bit pattern, that is 8, sorry, that is F0. Clear? So this bit pattern will tell us that the timer 1 is using as a timer and the mode of operation is 13-bit timer mode 0. Clear? Any questions? Any questions, or I will proceed? Okay, so no questions, we are proceeding. That this figure actually depicts how the timer operation is occurring, and this specifically, especially this diagram denotes that when this gate pin is high, then in the TMOD register, then what will happen? Now, as we have seen, just I'm removing all the things. Yeah. So if we go back, just see the clock source of the timer is the 1/12 of the crystal frequency. Okay. So here is written that this is the thing. Okay. That 1/12 of the crystal oscillator frequency. That means nothing. That means the crystal oscillator frequency is divided by 12. 1/12 means, and the input of this particular timer, that is coming here. Okay, and when counter or timer operation is equals to 0, then timer operation will be there, no counter operation will be there, because C is 0, T bar is 1. Okay, and T0 pin of pin 3.4, you can go back to the pin configuration of 8051 microcontroller. Okay, so that is used for the external pulses. When that will be when some external operation is to be counted, then counter operation will be there. So here is written C oblique T bar is 1. When counter operation will be there, this switch will be connecting to this point. Clear? Now at the bottom part, just see that gate. Okay, this
Sir,
gate is
sir,
yeah. Tell me.
sir, T0 pin is pin 3.2, na, sir?
Okay, then I
Or,
might have made some mistake. So
yes,
you
sir.
please be correct with that. That
Okay,
is
sir.
pin port 3.4 is there, or 3.2 is there, whatever. But this should be T0 pin. Okay.
Yes, sir. Yes,
Okay.
sir.
So this INT 0, you can see this INT. You have probably you have told like this only, because 3.2
Yes,
is
sir.
the
Yes, sir.
INT 0. Okay.
Yes, sir.
So
Yes, sir.
so INT 0 pin and gate pin. And what kind of gate is this? This is the what kind of gate? This is
Nor gate, sir. Sorry.
what?
Nor gate. Not an or gate, sir.
Uh, this gate is OR gate. Okay.
Yes, sir.
Okay. So when this pin is 1, suppose this pin is 1. Okay. So output of this will be 0. Okay. Only when this INT pin is high, just going back to the thing, uh, only while the INTX pin is high. Clear? So when this pin is high, that means this input will be 1. Okay. Oh, sorry, this some overwriting is there. Just a minute. So this will be 1. Okay. So as this is the OR gate, so if any input is 1, then output will be 1. So this will be 1. Clear? Again, I am going back. That TRX control pin is set. That means TRX. That means here that is pin number whatever is in the pin diagram. That TR0 pin, this will be set by 1, and you know that when both the inputs of this AND gate is 1, then the output will be 1. Otherwise, it is not. So I am repeating once again. The gate pin is 1. Here the condition is given at the top of this PPT, this slide. So if this is 1, then after complement this will be 0, and when INT0 pin is high, then only the output will be high. And this is 1. When this output will be 1? When this TR0 pin is high, then so 1 means this switch will be closed. Clear? Clear or not?
Yes, sir.
Okay, any questions from any other? Okay, so that was the timer mode register. So TMOD register has been there. So along with this TMOD register, another register is the timer control register. Okay. Okay, so before going to this, actually I need this thing badly. There was a problem of joining in the Zoom meeting. I don't know why. Did you face same kind of problem while joining?
Yes, sir.
So how did it, I mean, how did the problem get resolved?
Sir, I have logged out my account from the Zoom and just log in, join the meeting directly.
Okay. Okay, for I suppose the copy is visible or not? The copy is visible?
Yes, sir.
Okay, so let me write over that TMOD register. Okay, so now just we have what we have seen, that TMOD register, that is gate C oblique T bar M1 M0, and again so here just I am writing. Are you seeing the video from the opposite side? Are you seeing the video in the right direction?
Sir, please bring the copy towards your right slightly.
Is this okay?
Towards right, sir.
No, if I am writing
Yes,
like
sir.
I'm writing Chaibasha. You are you seeing my writing from left to right or right to left?
Left to right, sir.
Left to right.
Yes, sir.
Okay. So I'm writing here. Okay. So I'll write here only. So in the T mod register, we have seen C oblique T bar M1 M0 get just a minute. Seeing some kind of problem. Yeah, now it is fine. Get C oblique T bar M1 M0, right? So this is the bit patterns of this T mod register. So now we will see, just getting back to the thing. Yeah. So there are four modes. Okay. When M1 M0, that is 0 0, then mode is 0, 0 1, that is mode 1, 1 0 is mode 2, 1 1 is mode 3. Clear? So in these modes, in the first one, there is a 13-bit timer mode, that is 16-bit timer mode, 8-bit auto reload mode, and split timer mode. Okay, so these four. Now in 13-bit mode, in mode 0, there is 13-bit mode. What is there? It counts from 0 0 0 0 to F F 1 F. Okay, this is a 13-bit timer mode. 0 0 0 0 H to FF 1 FH. Okay, and in mode 1, that is 16-bit mode. That 16-bit mode means is fine. So this 16-bit mode means it will count from 0000H to FFFFH. Okay, and this what will be the delay? Now you need to calculate the delay. Okay, so how to calculate the delay? Now there is a formula. Okay, I'm just writing the formula. Go to this page. Okay, so here the formula is the delay, that is equals to, the delay equals to 256 minus THX plus 1. This is very important formula, into 256. Okay, plus 256 minus TLX. Okay, now I am closing the brackets, divided by crystal oscillator frequency, and this is multiplied by 12. This is the calculation of delay. Is it clear? The formula? Is it clear? The formula is clear. and this is this delay is for the 16-bit timer mode. Okay. Now, if someone, I mean, if the question is like, if the value of, just a minute. Yeah. So if the value, that means if the value is suppose THX value, that is CD, and TLX value, that is F2. Okay. Now delay when mode 1 operation. Okay. Now delay when mode 1 operation. So in mode 1 operation, that means 16-bit mode. So you just need to remember this formula. Just remember this formula. So we will write what? The delay equals to 256 minus CD. We need to convert it to its equivalent decimal form. So CD, that is, we are writing here. CD, that means C means 12 into 16 to the power 1 plus 13. So that will come like 192 plus 13, that is 205. Okay, this is in decimal. So 256, that is THX plus 1, that formula is there. So 205 plus 1, that will be 206. Clear? That will be multiplied by 256 plus 256. This is F2. So again F2 calculation will be there. F2, that is 15 into 16 to the power 1 plus 2. That will be like 240 plus 2, that is 242. Okay, that is 242. So this, there will be 242 as per the formula. We are going as per the formula, and crystal oscillator frequency is 11.0592 megahertz and into 12, that is for the clock cycle. So here if we this is 50 into 256 plus 14, that is, sorry, 11.0592 into 12. So if we calculate, just a minute, I need to calculate it. You people can also calculate. It is coming like 13.904 microseconds. Okay, you can calculate it. So near about 13 to 14 microseconds delay will be there. So is it clear how to calculate the delay by using the timer? Is it clear or not? And for this 13-bit mode, for this 13-bit mode, we will see that the formula will be there, like delay equals to 256 minus THX plus 1, that will be same as before. And for this 1F, you just see that 13-bit mode will calculate from 0000 to FF1F. So this is the higher part and this is the lower part, 1F. 1F means what? 1F means 32. So that will be multiplied by 32. Plus, and lower is maximum is 32. Unlike here was FF. So this is 256. So this will be 32 minus TLX. Okay. That will be FOSC. And that will be multiplied by 12. Is it clear? Is it clear to all of you? Is it clear to all? Okay. So if anyone is having any question, then you can ask. Okay, so perhaps you are not having any questions. So if you are still having any questions, then you can ask over, you can note it down for the next class. We can discuss it in the next class also. Okay. So thank you. Thanks to all of you. We are concluding our today's class.